Hey, welcome to Math Head X. Today we're going to be going over in Algebra 2 and we're going to be looking at linear equations with one variable. So in this case, as we see here, we have 2y plus 5 is equal to 0. So pretty much what this is telling us is everything on this side, no matter what it is equal to this side. In this case, it is 0. So in order to solve these problems, which are linear equations with a single variable, all we need to do is isolate that variable and push everything out onto the other side in order to find its value. And then we can confirm that it is its value by plugging in that answer back into y and solving it and see if we get the same sides to equal each other. So let's go about doing it. In this case, I see that there's a constant sitting on the end, which is 5. And so I can know that I can move this on both sides. And since this is equal to this side, all I have to do is do the same thing to both sides to keep it at the same value. So what I mean by this is, if I subtract 5 on this side, well then, since these are equal to each other, then I also need to subtract 5 on the other. So I'll subtract 5. And now, we are left with 2y, that looks a little bit messy, let's make it look a little bit nicer. 2y is equal to -5. Now, all we have to do is divide the 2 from the y onto both sides. So when we see 2y, it's actually 2 multiplied by y and whatever value it is. So we're going to divide this by 2, and we're going to divide this by 2. From there, these 2's cancel out, and we have y is equal to -5/2. So we had just solved it, but we want to make sure that we did this problem correctly. We want to make sure that we had solved it. So let's go about doing that. I'm going to now plug this. Since now we know what the value of y is, we could input it into here. So we have, I'll separate this with a line. We'll have 2 multiplied by -5/2 plus 5 is equal to 0. Now, let's go about solving this part. Well, we know that 2 is equal or equivalent to saying 2/1. I'm sure many of you would agree. 2/1 is the same thing as saying 2 multiplied by -5/2. So we have 2 times -5, which is -10. And then 1 times 2, which is 2. And then we have -10/2, which is 10 divided by 2, which would give us -5 plus 5, as we see here, is equal to 0. And now we see -5 and 5, they are the opposites of each other and they cancel out, and therefore we get 0 is equal to 0, which checks our answer for y is equal to -5/2. And that is how you solve this for section 1.1 of Algebra 2. Now, we're going to move on to our next example. Now here, we see that we have an x on both sides. This is also the same thing as the last problem, except we're just going to have to move these together. So we're still working with a single variable, in this case x instead of y, and what we're going to do is we're going to isolate this once more. So it's the same process, just a couple more steps in the way that we do this. My first step, and you can approach this whichever way that you wish to. For me, I'm going to move the value of x onto one side. So I'm just going to add the 2x. So we'll do plus 2x, and since these two are equal, if I'm adding 2x to this side, I will also have to do it to this side to make sure that they continue to be equal to each other. So I'll add plus 2x here, which then gives us 6x plus 5 is equal to 10. Now, once again, we want to make sure that this x value is isolated to find its value. So we're just going to subtract this constant 5 on both sides. From there, we are left with 6x is equal to 5. So now, since we have 6 times x, we're going to do the opposite and divide that 6, once again on both sides. And we are left, these cancel, and we are left with the result of x is equal to 5/6. So, we're going to check this problem just as we did the last. Or you can, just skip to the next question. It'll be in the description some shit. I don't know.
Not our job to worry about that.
Yeah. Zach. Thank you, Zach. Man behind the camera. So we're going to once again plug in this into x. So we have our original problem here. Or if you want, since this is the same thing as this, these are the same thing, right? We did the same change to both sides. So this is the same thing in here, unless you're worried about making a mistake on maybe on your homework or on an exam. In that case, I would recommend plugging it into the given starting problem. But in this case, we know that this is done without any error. So I'm actually just going to plug it into this one, so that way I only have to plug it into one of the x values. So we're going to work with 6 multiplied by 5/6 in substitution of the x value, plus 5 is equal to 10. Now, I know last time, on the last example, I did the 2/1. In this case, it would be 6/1 times 5/6. But in this case, we can actually just ignore that. We don't have to do it sounding out. I just wanted to start it off with keeping it within these simple algebra bounds. What you can actually do is just cancel these out. These 6's can cancel just as these 6's can cancel. And I'll show you why that's the case. As we see here, this 6 times 5 would give us 30 over 1 times 6, which would be 6. And then 30 divided by 6 is equal to 5. They're equivalent. And we'll find this to be the same case. As long as this part in the numerator is equal to the part in the denominator as they're multiplying, they will cross cancel out. And then 5 times 1, or 5 and 1, and then, or 5/1, excuse me, would just be 5. So now we are left with this being 5 plus 5 is equal to 10. And I'm pretty sure we can all agree on that. All right, we're going to have one more example here. We're going to be going over the problem 3 divided by x plus 2 is equal to 9. So once again, works similar, but we're going to do it a little bit different. So we want to get this x value, but it's in the denominator. So how would we go about making sure that this x is just isolated on itself? Well, what we're going to have to do is, once again, all of this side is equal to all of this side. If we let that equal a and that equal b, they're all equal to each other. So once again, we're going to have to do the same thing on both sides. In this case, because 3 is being divided by x plus 2, we want to do the opposite on both sides. So we want to multiply by x plus 2. And no, we can't just multiply by x and then everything will just go to hell. Because if we multiplied by, let's say if I did multiply this side and this side by x, then we would be getting 3x plus x plus 2. And we won't be able to cancel out this 3x and x plus 2 because of this 2 here. If this was a 2x and this was an x squared, then yeah, we can cancel these all out. But because of that constant in the denominator, we are unable to do that. which I'll go over in a later video as to why. For now, don't worry about that too much. I'm not trying to overwhelm you with information here. So, the way that we are going to do it is we're going to multiply by x plus 2 on both sides. So, x plus 2 and by x plus 2. Very tiny. Can you see that? So these x plus 2, as we showed in the previous problem, where I did 6 over 1 and 5 over 6, I believe, 5 over 6, and these 6's just cancel out. It's the same thing, this x plus 2, maybe I'll try and make it a bit bigger here. So I'm not doing this amateur hour, but...
What is this, math for ants?
What? Oh, yeah. I see what you mean. I see what you mean. Ants with really good eyesight. So we're just going to cancel that and cancel that. And then we are left with 3 is equal to 9 times x plus 2. So we can approach this in a couple different ways. So we can either divide this 9 and then subtract this 2 to isolate the x, or we can distribute this 9 into the x, making it 9x plus 18. Now, I'd rather not do that, just because that's unnecessary amount of steps. We don't need to multiply this in just to get rid of it again and work with bigger numbers. The goal in this is to keep it as simple as possible. Simplify out the answer so that way it's more readable and you're working with easier things. And that's what you're going to be pretty much focusing on doing with your algebra skills all the way through calculus and linear algebra when you get there. For now, we're going to be just dividing that 9. And 9 and 3 are great friends because 9 is a multiple of 3. What does this mean? Well, these 9's are now is now equal to a 1. So this cancels because 1 times x plus 2 is still just x plus 2. And then 3 over 9 would be equal to 1/3. So this expression is equal to 1 over 3, which is equal to x plus 2. Now, we're just going to subtract the 2. Minus 2, minus 2. Step to this side. So we have 1/3 minus 2. Now I know for some, the visual of subtracting a whole number from a number like this, it can be a little bit confusing. But we can make them have the same denominator if that makes it easier. So how do we do that? Well, if we were to have this 2 over 3, we would have to multiply the 2 by 3. Let me show you. So if I wanted this 2 to be over the numerator for denominator 3, this 2, this would still have to be equivalent to the value of 2. So we would have to multiply that 2 by 3 as well to keep it the same, which would give us 6 over 3. 6 divided by 3 gives us 2. So we can have this, we can rewrite this as 1/3 minus 6 over 3, which would then give us negative 5/3. I know all these problems gave us numbers that aren't satisfying whole numbers like 2 and 4 and everything's kind of a fraction, but these are still good examples to work with, and it's important to practice your fractions, especially as you go later on, because if you get good at these things, it gets a lot easier when you encounter them when you're faced with them on your exams or homework or so on and so forth. So we now have x is equal to negative 5 over 3. So let's plug this in and test it out, right? So we're going to have 3 over negative 5/3 plus 2 is equal to 9. we're going to take it for the original. Now, we can do the same thing as we did prior to simplify this out a bit. So, if we have -5/3, we can make it so like this 2, which is equal to 6/3. So, we have 3 plus -5/3 plus 6/3. -5/3 plus 6/3 is equal to 1/3. So we have 3/1/3 is equal to 9. This is getting a little bit scuffed here. Everything's kind of writing over each other. So this has a denominator that's being divided. Well, the cool thing is a neat little trick. If you have a problem, and I'm going to erase this if that's okay. If you have a problem where you have, let's say it's A over B over C, this is the same thing, and you can utilize this trick as saying A times C over B. And you're going to be utilizing this all the way up through calculus as well, and so on and so forth as you go higher up in math. So, yeah. So what do we have here? We have A, B, C. So we have 3 times 3 divided by 1. So therefore, it would be 9 is equal to 9. And I would say that that is true. 9 is equal to 9. So therefore, our answer is, in fact, x is equal to -5/3. I hope you all enjoyed. This is my first video, so it might be a little bit scuffed. And I just hope that, we can do better to improve upon it and make better content. If you have any questions, feel free to comment them, and I'll be more than happy to help answer questions in the comment section. If you have something, let's say, a homework problem that is challenging you in this section or even a later section, feel free to leave it in. I'd love to maybe help you out in the comment section or even do a video using that question if I think it's a good example that many people would benefit from knowing the answer and how to solve it. Enjoy.
And tell them to like, share, and subscribe.
Make sure, who the fuck shares a fucking math YouTube tutorial video?
Fuck if I know, just say the goddamn line.
All right, fine. Like and subscribe if you are cool as fuck, because I have no subscribers. And
Be the first of our kind.
Yeah, be the first. Be the first. You can make this could be history in the making. If I somehow get 1 million subscribers, I'd fucking be like, dude.
We'll put your face in the plaque or something.
Yeah, you'll be tight as fuck. And if you're the 10th subscriber, that'd be cool too. All right.